about it. So this is, from Algebra 1, you guys, this is semester 2. You're going to make sure to follow the unit. This is unit on exponents, and this is the first lesson, 01, Properties of Exponent Practice. And that's the same way the Schoology assignment's listed inside of Schoology also. This is from Creator Math. Your instructions are to copy the following problems 1 through 25 into your composition book on the correct pages according to the table of contents, with the notes for those pages too. Don't forget the notes from creatormath.com. Okay? So here's what we're going over. Here's your first sample problem. This is x to the power m. And some of these are written kind of funky, so you're going to have to do your best to decipher them. This is x to the power m times, that's a dot there, means multiply, times x to the power n. And that's our question, and then they give us multiple choice. Just so you know, in this demonstration, my multiple choice answers are always on top. They're always the first answer, but in yours, when you take Schoology, it's going to rotate these and place them randomly, right? So x to the m power times x to the n power. What happens is we end up with this answer here where the powers end up adding. Let's see if my pen works. So this is x. Notice the caret right here. X caret m means x to the m power, right? So when this says caret m plus n, it means that you're taking x to the m times x to the n. When they multiply, the m and the n get added. And I'm going to show you why in a second here. All right, but start with that. Let's go to the next one. So this one is an example with a power 3 and a power 4. So here's how we explain this. X to the third power is really x times x times x. There's 3 of them, right, to the third power. And once you break them into 3, this is to the 1 power, 1 power, 1 power. And what happens is that's times an x to the 4th power. 1, 2, 3, 4, right? And so you have all these x's. How many do you have? 1, 2, 3, 4, 5, 6, 7. So you actually have x to the 7th power. So the way this works out is if we had just taken the power of 3 and added it to 4, we would have gotten x to the 7th. So this kind of sets you up, and it says x caret 3 plus 4. It's showing you how to do this. This is the proper answer here. Remember, mine's on top, but yours is going to be scattered somewhere in there. And now it's going to go straight down to this one down here. And just say jump to the final answer. Well, we know it's x to the 7. We've already calculated that. We've already done the combination up here. And then, so we're just going to come straight down here and say x to the 7th power. All right? And what x to the 7th power is? X times x times x times x times x times x times x. 7 of them, right? That's what a power is. It says take that base. This is the base, and this is the power. And sometimes students or teachers will call this whole thing an exponent, right? Okay, let's move to the next example. Number 4 is 2 to the 5th power times 2 to the minus 1 power, right? So what you got here is 2 to the 5th power. Notice, number 1, that our bases are the same. If our bases weren't the same, we would not be able to multiply them. So this is 2 5 times and 2 to the minus 1, but we're just going to go to the same method and add the powers. We're going to say this is 2 to the 5 plus negative 1. And we're going to get 2 to the 4th power here, because 5 minus plus a minus 1 is a minus 2 to the 4th. What's really happening here is there are 5 2's, and there's a times between them all. And then this is over. What happens when you have a negative power? It pushes that 2 down into the denominator position, and you get a 2 down here. So one of these disappears because 2 over 2 is 1, but these others 2 remain. 1, 2, 3, 4. So you have 2 to the 4th power, just like we set up here by adding the powers. Right? All right, let's keep going. And I apologize for rushing a little bit, but I'm hoping you can go back and watch this if I go too fast. Here we are again. They're just going straight to the quick answer without all the explanation. It's 2 to the 5th plus a minus 1, which equals 2 to the 4th power. Done. So it's just sort of an elaboration of the one we already did. All right, now we're going to divide. So we have an x to the m power divided by an x to the n power, and it's being divided. They have to tell us that x does not equal 0, because if this were 0 down here, we would have a 0 in the denominator, and that's not allowed for a fraction. So every time you see a fraction, you're going to see this kind of, at least you should, if I did my problems right, you should see that that denominator cannot be 0. Well, what happens when you have an m and an n, a power, and they're being divided is these things get subtracted. All right, so what this equals is x to the m minus n. And to explain that, let's look at this problem here. This says x to the 10th power divided by x to the 4th power. So let's write it x to the 10th and put the divided in there, x to the 4th, okay? Then let's explain what this really is. X to the 10th power is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I always wish I used a smaller power once I start writing them out. Once I have to write out 10 of them. And there's a multiply between them all. And these all are to the power 1. Okay. All right. Then this is over 4 x's, right? The same way. X to the 1 times x to the 1 times x to the 1 times x to the 1. Since each one of these lines up, x over x is 1 right here. And there's another over it here, and I should have been a little bit more careful to line them up. Would have been better on my eyes. Each of these turns into 1 times what's left. There's 1, 2, 3, 4, 5, 6 x's left. So we have x to the 6th power left. And if you just look at what happened, we set up here m minus n. If we had just gone x to the 10 minus 4, we would have gotten x to the 6, right? So this is the long way, the proper way to explain it. This is the quick way to do it once you kind of understand how it works. And so down here they repeat the problem, and they just want us to pick the right answer, x to the 6, and just do a quick, if it's x to the 10 divided by x to the 4th, then this equals x to the 10 minus 4th, which equals x to the 6. Done. All right. Now let's keep going. Let's reverse a different way. We know it's the top power minus the bottom power as long as the bases are the same, and they are in this case, x to the 4th divided by x to the 7th. So let's draw this out. This is 1, 2, 3, 4 on top, and this is 7. 1, 2, 3, 4, 5, 6, 7 on the bottom. These cancel. Okay? And so what we really have is 3x's on the bottom. Anytime we have 3x's on the bottom, this is like saying 1 over x cubed, or we can move it up and say x to the minus 3. And this minus moves it from the denominator position up to, this was over 1, up to the numerator position, right? That's what a minus does. It switches the position between that power. Between the base and the power, the whole exponent moves from one position to the other, depending to get rid of the negative or to add it. And if you look at the original idea that we could subtract these, if we literally took x to the 4th minus 7, wouldn't we get an x to the minus 3 here? So we could have done it the short way, or we can do it the long way. Okay, hang with me. But wait, there's more. Here they want us to go ahead where we can see it. There we go. Here they want us to just do the quick way. They want us to take x to the 4 minus 7 and say x to the minus 3 and circle the right answer. Remember, you guys, the notation here. It's x caret minus 3. This is the way you would type it into Google, right? Because we have Google these days, you can't sort of use powers and things. Doesn't type in well. Caret is shift 6 on your keyboard. All right, shift 6 is how you get the caret right here. All right, let's keep going. Let's go to another case. Here we have y to the third power divided by y to the third power. The bases are the same. These are the bases, so that's okay. We can divide them. Let's use the quick method, 3 minus 3. What is 3 minus 3? It's y to the 0 power. Here's the interesting thing. Remember that any number over itself equals 1. So here we have 3 minus 3, we get y to the 0. But guess what y to the 0 equals? 1. This is a classic trouble spot for students, because if you ask them what is x to the 0 or 3 to the 0 or y to the 0, their brain wants to say 0. But it's not, it's 1. So here's the answer they want from us. Y caret 3 minus 3, that's the proper way to do it. Here's the explanation where now they're saying, oh, that's y to the 0. Right? And then over here, they're going to take one step further and say, all right, now that you know that much, what is y to the 0? Y to the 0 is 1. Likewise, anything to the 0 power, for example, this next one, I guess we could leave that up there, 3 to the 0 power also is 1. And we could just make up a situation. Say we say 3 to the 1 power divided by 3 to the 1 power. Isn't this equal 3 to the 1 minus 1, which equals 3 to the 0? And isn't 3 over 3 1? Okay, that's why anything to the 0 power equals 1. All right, and it could be a 3, it could be a y, or it could be an x. X is your most classic, right? Everybody says, what's x to the 0 power? It's 1, you guys. All right, let's keep going. We're down to number 15. So this is x to the m power, and it's raised to the power n. The rule with this is that it multiplies the power outside by inside, and I'm going to explain why in 1 second. But here's what it looks like, all right? X caret m times n. Let's show a longer form of this, a little bit better example. This says x to the 4th power, and I'm sorry I didn't print very well, you guys, but it says x to the 4th power raised to the 3rd power. What does this mean? It means there are 3 x to the 4ths. So 1, 2, 3. That's what power 3 means. It means 3 of these multiplied. Whoops. Excuse me, you guys. I said 3, and my brain said 3, and I wrote it. It means 3 x to the 4ths. All right? Each one of these is 4 x's. 1, 2, 3, 4. There we go. There's 3. There's 1 here. 4, 4, and 4. How many you got? 4, 8, 12. Right? So this really equals x to the 12th power. If we had just multiplied these, right, like we said we did up here, m times n, it would be 4 times 3. We could have gone straight down here and said x to the 12th. They want us to show it's 4 times 3. Then when we come down here, they want us to go ahead and just multiply it and show that it's x to the 12th. Okay, here's another example. They're going to give us this one, 10 to the 5th power, and there's 6 of them. Whoop, I'm sorry. There we go. 10 to the 5th power, and there's 6 of them. It's to the power 6. 10 to the 5th to the power 6. Right? Well, we know what's going to happen. We have to multiply those powers. We stick with the same base. The base stays here. Before we had a y or an x or whatever, the base stays the same. Caret to the 5 times 6. Okay? Here we have, now they're multiplying it out. So there was 5 times 6. Here it's 10 to the 30th power. And looks like we're moving on. They gave us the classic x to the 0 power. I'm wondering what it is, but go back and think through what we just did. It's going to be 1. Move on to a couple more problems here. Here we have an x squared and a y cubed, and they're being multiplied. So notice how the base here is different from the base here. When the bases are different, these cannot be combined. It's a repeat. This is a trick question. This is it right here. X squared, y cubed. It cannot be changed. This is the right one. See how they're trying to trick us here by combining them? No, 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 no. This is wrong, wrong, wrong. Okay? Let's see. Now let's move on to negative powers. Like we said before, if it's 1 over x to the negative 1, this negative can be moved to the other position. So this can come straight up to here, and this can be just a 1. So this can be x, right? So here's the answer right here. Let's look at a couple more of these with negative powers. And the negative on the power can be eliminated by moving it to the other position. So here we have an x to the power 1. If we move that up to the numerator position, we need to add a negative to the 1. So this becomes x to the negative 1. The negative tells you to move it to the other position to get rid of the negative. So in this case, it's a positive, and it becomes negative. So that's this one. Notice x caret negative 1. That's what this is. Follow that notation. Here we have an x to the negative 1, which means you can push it down into the denominator position, and now the negative disappears. So here we went from here to here, up. Now we're showing it back the other way, and now we're going to show this one, right? So this is 1 over x. Now we're going to show this one right here. X equals, I know that x equals, right? It's not 1 over x, no. It's not 1 to the negative, or x to the negative 1, no. But it can be that you push this down to the denominator position, put a negative 1 on it, and it can be 1 over x to the negative 1. Right? So I hope this helps. You're going to mirror the problems from creatormath.com as you watch this video. Okay? Hope it helps.